Now that you're writing small code fragments, we're going to look at the basic concepts in testing software. In particular, we're going to consider how to perform what is called a unit test. Let's look at the fundamentals of testing. Software testing is a critical element in software quality assurance. It represents the ultimate review or the final review of the requirements, the specification, the design, and the code. And it's the most widely used method to ensure software quality. Now, many organizations spend a huge amount of time testing, and it can be 40 to 50% of their time. And when you write software, you've got to consider the testing aspect, and it's very common to simply write your software, have it work for one simple test set, and then consider that this software is going to work for all test sets. So what I want to try to impress upon you is to create a set of test conditions and make sure that you fully test your software module before you pass it in. Now, testing is something that takes time sort of to develop as a skill, and so the more you do it, the better you'll get at it. Now, testing you can actually consider as a destructive type of process, because what you're trying to do is you're actually trying to break your code. So a successful test is one that uncovers an undiscovered defect, something you didn't know existed. And too often we want to try to, sort of the natural tendency is to write a test that validates and sort of shows that our code is actually working, but that's actually the wrong way to come at testing. Now, just because your software actually passes the test doesn't mean there aren't any bugs or defects in your code. It only shows that there are no defects for that one test. Now, you can always do exhaustive testing. A simple example would be to multiply two numbers together. Well, we're not going to test an infinite number of numbers just to make sure that this works. So, part of the art of testing is to try to develop a set of test conditions that will effectively test your software and try to pick up as many defects or bugs as possible. Let's suppose you're on a team that's developing a payroll system for an organization, and you're not part of that organization. They've contracted your software company to develop it. So you maybe you're in a team of 5 people, and you're responsible for writing one major module. Now, a module or a unit, because we're going to test at a unit level, so this could be a code fragment, just maybe 10 to 100 lines of code that perform some task. Often, though, these are called modules, which are functions. In object-oriented programming, you're writing a class. So this concept of unit is sort of a little vague, but you have the job of writing one unit for this, and there are other members of the team. So you have 5 members of your team, and they're all writing one or more units. Now, what we're going to focus on here is, for your unit code, it's really important that you do a unit test. And what you're trying to do at this point is just make sure that this little module works as specified. Now, we're not going to focus on the complete testing regime, but we're going to mention it here just so you see how that flows into the whole project. So once all the units are constructed and you've tested it with your unit testing, they're all put together into your payroll system. Sometimes you'll find that if the payroll system can modularly be broken down into, let's suppose it can be broken down into two major components, you might just take the units for, say, 3 of the team members and put those together. And you do what's called an integration testing. You put them together and you perform some tests that exercise the what that sort of module is going to do that includes the 3 units. But eventually you'll put all those units together into a complete payroll system, and you do an integration test. How well do these integrate together? Can I get information from one unit to the other? Are the units communicating properly? Finally, you're going to do a function test here. So does your payroll software as a whole do what it's supposed to do? Does it generate the checks? Is it keeping track of the payroll properly? Performance testing is things like how well does the software work from a user perspective? Is the user interface good? Is it fast enough to adequately do the payroll for a large organization? Maybe this has 10,000 employees and you've got to perform this in a certain amount of time. Is it able to generate enough checks? Do you have enough disk space to hold everything? So how's the system performing under an actual fully loaded condition? The customer is going to eventually get this software, and the customer is going to do an acceptance test. They're going to say, yes, these modules work as expected, or yes, these do, but here are some enhancements we would like, or this module doesn't do what we expect it to do. We want you to correct this. And so you'll find that this is often an iterative process. At some point, if something's not right, we'll go back, we'll make some changes, and you'll step through this again. Finally, you're actually going to install this at the customer site. You're going to put it under an actual load. It's in use, and you're going to see how it performs. So this is the sort of in a snapshot, the entire process of testing. And as we mentioned in an earlier slide, this can take a great deal of time. But we're going to focus on unit tests, and we're going to go over an example of how you might perform unit tests on your code modules. Now, here's an example from our last assignment, and what we asked to do is to check to see if the second number in a list that a user enters is a divisor of the first number in a list. And I've written some code here, and there's some elements of the code that I want to draw to your attention. And the first here is that make sure that you add some comments at the top to sort of say who you are, the date that maybe you wrote this, and sort of an overall description of what this code fragment's doing. Throughout your code, you can put comments, and this is sort of the octothorpe is the common way to add comments into your code. So I've got a if statement here and an else. This describes what that's doing. You don't need a lot of comments through your code. Your code should be readable. You should try to write it so it's as readable as possible. Don't try to put 5 lines on one by writing some code, putting a colon, another line, a colon, another line. That's not readable. So even though you can do it and it seems like you're putting it all in one line, that's not going to be very good for testing as well, because people aren't going to understand how it works. It's going to be hard to debug. Make your code as readable as possible. The other thing you should do is get into the habit of using meaningful names. Don't just use X, Y, and Z for variable names. So in list means it's an input. It's going to be in a list format that I'm trying to get. And so that's what I've used here as my variable name. I've used an input statement, but what an input statement does is it just gets a string. We want that string to get converted to a list, so we need the eval. So then we do a little if statement here to check if the first number in the list is divisible by the last number in the list. And we assume the user is going to enter only 2 numbers. We don't need to do a bunch of error checking on this at this point. And I've given you some possible test cases, or recommended some. For instance, we could test on 16.4 to see if that works, and one where, and so that should test this path. So when you have some paths, some if-else, and you can test each path, this should test the first path where this is true, 16 is divisible by 4, and then we're going to make another test set where it's not divisible by 4. And I may have given you these on the assignment sheet, but you shouldn't limit yourself to that testing. I want you to demonstrate to me that you've tried to break your code and that you've done it for other testing. So what other tests could we perform? Well, often the numbers 1 and 0 are magical numbers, so maybe we'll test for those conditions to make sure they work. What if I have 0 as one of the numbers? What if I put a list with nothing in it? What if I put a list with 3 numbers in it? Now, at this point, I'm just trying to find ways to break my code. What if I put a list with a letter and it's not a number? Now, sometimes we don't need to fix our code if it doesn't work for some of these. That was an A, not a 2. So as we execute that, oops, we notice right away we've got a syntax error, and I've forgotten a colon here. So syntax errors are the first level of testing. Okay, so enter a list of 2 numbers, and so we need to enter the actual list format. We'll put in our first test case that I had erased, but put back. And we'll see that 16 is not divisible by 4. So already I've seen and picked up an error because it should say is divisible. So let's go up and take a look at what's wrong here. So we've checked that the first mod the second, right here I should have equals 0. Okay, and we'll restart this. And we'll see, okay, so it now passes the first test, and we can check that off. We'll run this again. And we'll do our second test. So it's not. And we've now tested both parts of our if statement. But don't think that you have no errors in your code. What if we did the rest of these tests here? Okay, 0 is divisible by 8. Well, I guess it is. I don't know if that's defined as a divisor 0, but that's fine. Let's try the other one. 8, 0. Now at this point I actually get an error, traceback error. Why is this? Well, when we actually do this modulus, we're actually getting a 0 division error. It's actually taking 8, it's dividing it by 0, and that's not allowed. You can't divide numbers by 0. Even in algebra, it's an undefined error. So we need to modify our code to handle that if we want to, and we should try to make sure as much as possible we don't get these types of errors. So we're going to show you a modification of our code here. Here we've modified it and said if the second number is not equal to 0, then let's do this as normal. But if it is equal to 0, we'll do the else, where we'll print a little message. And you can see here I've used a double quote. Here I've used a single quote. Python treats the double and the single as the same type of thing, so it doesn't matter which quote you use. So let's do our test again. 8, 0. And now it doesn't crash, but it does give a nice message back to the user. Okay, what about an empty set like that? So we do get an error, but maybe we don't need to correct for that. Just be aware that if you do pass it an empty list, that you will get an error. What if we do this? 15, 5, 2. And in this case, we'll see that the second number is a divisor here, but we've got 3 numbers. And if we run this, 15 is not divisible by 5. Now, here's what's happened. We've done the test up here with a -1 because we assumed that -1 would be the second one. But if we enter 3, that -1 is actually testing 2 here. Well, there's a few things we can do here. We can change this up here to be 1, which is the second one. And then I can handle, I'll do it here too, then I can make sure I handle the fact that if I have a list of 3 elements that I'm actually only considering the first 2. So we're going to run this again. Oops. And that's going to work properly. 15 is divisible. Here I got the not divisible message. Finally, and I really don't care right now if I enter a letter. I'm just sort of interested to see what happens. And I do get an error. So this shows some of the weaknesses of your module, but you don't need to correct for all of them. So what we've done is we've written our test. You had tested it for those first 2, but for all the code modules that you write in the rest of the course, come up with your own set of test conditions and show those to try to exercise your code. Remember, your intent is to try to break the code. We'll do one more example. So here we've got a little example where we want a user to type in a month, and if the month ends with in ER, we want to tell the user, nice job. And if it doesn't end in ER, we want to say, try again. So we're going to input the month, and notice we don't use the eval statement here because we just want a string as input. Now if the month is September, we're going to print this. Else, as an elif, month is November, print nice job. Elif, month equals December, print nice job. Else, print try again. Now, some of the things here I want to illustrate is this idea of meaningful variables. We've used month. One of the things that should raise a red flag is whenever you have code that's duplicated, you should try to avoid that. Maybe you wanted to change the error message to OK, and you change it here and you forget to change it in other places, then you get error messages which aren't consistent. So how can we combine that first off into one module? So sometimes testing is done without actually writing the code, or without, running the code. And this is called some static testing. Okay. So there are a number of ways that we can actually do that. We could say if month equals September, or, and I can't just put or November. That doesn't work. If month equals September or November, you've got to say or month equals November. You could put or, oops, closing, or month equals, at the end here I could put or month equals December. And then I could get rid of all this stuff. Okay, that would be nice. It's a little long. Sort of a nice technique is I could use the in. Maybe month is September. Oops. November, December. So I could say if the month is in one of these three, meaning if what's in month is this or this or this, if it's in here, then this will be true and we'll print that. So let's look at creating some test sets. And so obviously I could have a test set where I'm going to enter the string November and one that's April, so that'll test both conditions here. What if the user doesn't capitalize it properly? Or what if it just says NOV? What do I want to do? So those are some tests that I've constructed. Let's see what happens here. Invalid syntax. Okay. Colon. Enter a month. So my first test. Nice job. So that passes. Let's try test number 2. April. Try again. So we've tested this loop here. What about so the user has actually added the month, but it didn't recognize it. Now how would we, there's a couple of ways we could do that. We could say, I'll use uppercase or lowercase. I could use capitalize. But how about if I do this? Month equals month dot lower. So this lower is called a method. Month is a object that is contains a string. So this is a string object, and strings have these methods like lower and upper that converts all the information here to lowercase. So let's see if that works. That didn't work. So sometimes when this doesn't work, one of the things that is your friend in the in testing is actually the print statement. You should make lots of use of print statements. So here we're going to print month and see what's sort of happening as we run along. And sometimes these can sort of show you what's wrong with your program. So as we do this, yes, I'm putting this in. It treats this as November. I do get a try again though, so we haven't checked to see whether the lower is really working. What if I did this? Yeah, it is converting it to lowercase. But I'm checking here for a capital S here. So I've got to change all these to lower cases as well. Oops. So let's try this again. Now we get nice job. And you might want to go back and make sure that some of the others at the top of your list here continue to work, because sometimes when you make changes you may break something from before. And if we just put NOV, well, doesn't matter. That NOV doesn't work. We want the user to type the full number or the full word here. So this is how you should be testing all your code fragments. Write your code, test them on the using the test set that I recommend, or that's recommended in the assignment, but then try to break your code with some other tests, perform at least 1 or 2 other tests, or really as many as you feel you need. Modify your code if you think you should handle it. You don't always need to make sure that your code works in all cases, but try to find weaknesses of your code and include those runs and examples in your assignments. So that's just an introduction to testing to try to give you sort of a feel for how you should be developing the testing of your code fragments.